Welcome to G Fun Facts Online. Today, we're going on a journey deep into the Earth, not with drills and shovels, but with science and policy. We're talking about a source of clean, renewable energy that's constantly running, 24/7, right under our feet. It doesn't care if the sun is shining or the wind is blowing. It's geothermal energy, and while it might sound like science fiction, it's a very real and powerful tool in our fight against climate change. But harnessing the planet's internal heat on a global scale isn't just a technological challenge, it's a policy puzzle. So today, we're going to explore how we tap this incredible resource, why it's such a game changer, and what legal and financial frameworks are needed to unlock its full, world-changing potential. Let's start with the basics. Geothermal energy is, quite simply, the heat generated and stored within the Earth. This heat comes from two main sources: the original formation of our planet and the continuous radioactive decay of elements in the Earth's core. To tap into this, engineers drill wells, sometimes several miles deep, to reach underground reservoirs of hot water and steam. This superheated fluid is then brought to the surface, where its power is used to spin turbines and generate electricity. And because modern geothermal plants can operate with minimal to no greenhouse gas emissions, it's an incredibly clean way to make power. There are three main ways we do this, each suited for different geological conditions. The oldest and simplest method uses what are called dry steam power plants. These are quite rare because they require a very specific natural phenomenon: underground reservoirs that produce pure steam. The plant simply pipes this steam directly to a turbine. The world's largest geothermal complex, the geysers in California, primarily uses this method. The most common type of plant today is the flash steam power plant. These are used where the underground reservoir is filled with extremely hot, high-pressure water, typically above 182 degrees Celsius. When this water is pumped to the surface, the pressure is suddenly released, causing it to instantly flash into steam, which then drives the turbines. But the real technological leap forward comes with binary cycle power plants. These are game changers because they can operate in areas with much lower water temperatures, dramatically expanding the number of places where geothermal is viable. In a binary plant, the hot geothermal water never touches the turbine. Instead, it flows through a heat exchanger, where it heats a secondary fluid or a binary fluid that has a much lower boiling point, like an organic compound. This secondary fluid vaporizes at a lower temperature, and its vapor is what spins the turbines. The whole system is a closed loop. The geothermal water is re-injected back underground, and the binary fluid is reused, meaning these plants have virtually zero air emissions. Beyond just making electricity, this heat can be used directly for heating entire districts of buildings, warming greenhouses for year-round farming, or powering industrial processes. Now, in a world crowded with renewable options, why should we pay special attention to geothermal? The answer lies in its unique advantages. Unlike solar and wind, geothermal is not intermittent. It provides constant, reliable, 24/7 baseload power. This is incredibly valuable for maintaining a stable electrical grid. When you have a power source that you can count on, day or night, rain or shine, it becomes the backbone of a renewable energy system, balancing out the fluctuating output of other sources. The environmental benefits are massive. By replacing fossil fuels, geothermal directly cuts down on greenhouse gas emissions. As we mentioned, binary cycle plants are near-zero emission systems. Furthermore, geothermal has a surprisingly small physical footprint. A massive amount of power can be generated from a relatively small plot of land because most of the infrastructure is deep underground. This minimizes the visual impact on the landscape, a stark contrast to sprawling solar or wind farms. Then there are the socioeconomic benefits. Geothermal projects are job creators. Studies have shown they create more long-term jobs per megawatt installed than both wind and solar. These projects are often located in rural areas, bringing economic diversification and stable, well-paying employment that can last for decades. This development strengthens local economies through taxes and royalties, and boosts a nation's energy independence by reducing its reliance on imported fossil fuels. So, if geothermal is so great, why isn't it everywhere? The single biggest hurdle is the high upfront cost and significant risk of the exploration phase. Drilling an exploratory well can cost millions of dollars, with no guarantee of finding a commercially viable resource. It's a huge financial gamble. This is where policy becomes absolutely critical. Governments can't drill every well, but they can create a landscape that encourages private companies to take the risk. Effective policy de-risks projects, attracts investment, and builds a stable market. A strong geothermal policy framework usually has three key pillars: financial incentives, streamlined regulations, and direct support for exploration. Let's break those down. First, financial incentives. These are essential to level the playing field with established fossil fuels. One of the most powerful tools is a tax credit. The U.S. Inflation Reduction Act of 2022, for example, significantly boosted tax credits for geothermal projects, making them far more attractive to investors. Another powerful incentive is the feed-in tariff, or FIT. A FIT guarantees a long-term fixed price for the electricity a geothermal plant produces. This price certainty removes a huge amount of risk for developers and has been a key driver of geothermal growth in countries like Turkey, Indonesia, and Germany. Governments can also provide direct grants for the riskiest early stages, like initial surveying and exploratory drilling, or offer low-interest loans and loan guarantees to make financing easier to secure. The second pillar is a clear and efficient regulatory framework. Navigating a maze of permits can kill a project before it even starts. Governments can help by streamlining the process, perhaps creating a one-stop-shop agency that coordinates all the necessary approvals. It's also vital to have clear laws that define who owns the geothermal resource. Is it the landowner, the state? Is it considered a mineral or water? Without this legal clarity, investors will stay away. The third and perhaps most important policy pillar is directly de-risking the exploration phase. This is the critical first step. Some governments have taken the lead by conducting their own geological surveys and exploratory drilling. Kenya's state-owned geothermal development company does exactly this. They find and confirm the resource, and then invite private companies to bid on building and operating the power plant. This model has been hugely successful in attracting private capital. Other solutions include government-backed insurance schemes that cover a portion of the cost if a drill comes up dry, or creating public databases of geological data to reduce the guesswork for private firms. We can see these policies working in several countries around the world. Iceland is the classic pioneer, leveraging decades of government-supported research to harness its volcanic heat for both electricity and heating for nearly all its buildings. As mentioned, Kenya has become the leading geothermal producer in Africa by using a public-private partnership model, where the state handles the risky exploration. The United States is the world's largest producer by volume, and its new, long-term tax incentives are expected to spur another wave of growth. But building a successful geothermal industry isn't just about geology and finance. It's about people. Any large-scale energy project needs what's called a social license to operate. This means earning the trust and support of the local communities where these plants are built. The Olkaria geothermal field in Kenya provides a crucial lesson here. Initial development led to tensions with the local Maasai community, causing project delays. The project developer has since worked to implement a more inclusive engagement program, focusing on transparent communication, sharing benefits through community development funds, and prioritizing local hiring. This human dimension is non-negotiable for sustainable development. Looking ahead, the future of geothermal is incredibly exciting, thanks to new technologies and evolving policies. The biggest technological breakthrough on the horizon is enhanced geothermal systems, or EGS. This technology allows us to create artificial geothermal reservoirs in hot, dry rock. Since hot, dry rock is far more common around the world than natural hydrothermal reservoirs, EGS could make geothermal a viable option almost anywhere on the planet. Innovations in drilling, many borrowed from the oil and gas industry, are also making it cheaper and faster to reach these deep heat sources. As we move forward, a few key policy recommendations stand out for any nation serious about geothermal. First, governments need to elevate geothermal in their national energy plans, setting clear targets for its development. Second, they must create robust programs to de-risk those expensive early stages of projects. Third, ensuring long-term revenue certainty through contracts or tariffs is essential to attract the massive investment needed. And finally, we need continued investment in research and development and programs to build a skilled workforce ready to power this growing industry. In conclusion, geothermal energy is more than just another renewable. It's a fundamental, ever-present source of clean, reliable power waiting right beneath us. Its ability to provide baseload electricity with a minimal environmental footprint makes it an essential piece of a sustainable energy future. But unlocking this immense potential requires more than just engineering marvels. It demands smart, forward-thinking policy that creates a fertile ground for growth. By de-risking exploration, incentivizing investment, and building true partnerships with communities, we can finally tap into the Earth's foundational heat to power a cleaner, more prosperous, and more secure world for generations to come. The heat is on, and the future is bright.